everyone. We made a game called Voxelcade VR. I'm Samantha.
I'm Robert.
And I'm Beverly.
And Voxelcade VR is a VR arcade-themed dungeon crawling adventure that features randomized dungeons and has a whack-a-mole boss at the end of it. We got our inspiration from dungeon crawling games such as Crypt of the Necrodancer and Dungeons and Treasure VR. And we also got inspiration from more classic games such as Whack-A-Mole and Duck Hunt.
So the development of Voxelcade started with a brainstorming session where we created a game design document which included different components such as the dungeon layout, size and generation, the enemy types, boss information, player incentives, the technical specifications, which we decided to use Unity, and the coding style. We also met once a week to combine code and redistribute and reassign different tasks for the next week.
For the project, the source control we used was GitHub to manage the code and make merging our stuff easier. We also used Trello to manage who was doing what and what still needed to be done. The team roles, I made the dungeon generation, the health potions, treasure chest, picking up the hammer, where the boss door spawned.
I worked on the enemy AIs as well as the art for the enemies and the music.
And I worked on integrating VR and Oculus into the game, as well as working on the Whack-A-Mole boss.
For playtesting, we each brought a friend in to test the game. We took down notes of what they were doing in the game, their thought process on trying to complete a task, like finding the hammer or getting to the boss door. We made changes to our game based on their feedback. Some was the speed of movement was too slow, the difficulty was too high, as well as a few bugs with trying to get certain places in different rooms.
So we use the Unity game engine, and that uses the C# programming language. We also use the OVR package, which is the Oculus integration into Unity, and it's pretty easy to use. As for the AI, I worked on the boss, the Whack-A-Mole boss. So the moles had variance and standard deviation, so that's filtered randomness. So I would basically calculate those two values, and then if the deviation was too low, then I would select a new mole to go up. And the way I did that was by having a state machine on the moles. So each mole had 4 states going up, down, up and down. And so if it was going up or up, then you can hit it. But if it was down, then it could be selected to go up.
So also with the enemies, each enemy had a 3-state finite state machine of an idle, an attack, and a chase. So idle would have the enemies walk around the game space. The chase would activate when the player was in a certain range, and then the attack state would trigger when the enemy was close enough to the player to attack. For the enemy navigation, we used ASAR Search, which is built into the Unity nav mesh system, and we also had a player model added to the player to spawn for the enemy spawning.
For the dungeon generation, I used filtered randomness to determine the path from each room. So each room would have a hallway spawn depending on this generation. And the filtered randomness would prevent small paths, so like 4 rooms. And it would also get as many rooms into the dungeon as well as adding forks to complicate the path, so it's not just one pathway for the player. The health potions and treasure chest use filtered randomness to prevent spawning in the same rooms as each other, as well as not spawning where the player spawns.
And so now we'll show you a demo of our game.
So as you know, we have randomly generated dungeons. As you can see here, the corridors were randomly selected, so you can make sure to have a unique experience each time. And it does this using a connected nodes algorithm that Robert developed. Now as for the actual game, you spawn in the middle of the 9 rooms, and you have your Oculus touch controllers, which you can see by the blue hands. As you can see, we also have a map that tells you what floor you're on and what room you're in. So right now we encounter an enemy and we punch it. So we have a collider detection to make sure that it's destroyed when you hit it with your fists. To make sure it is destroyed, you have to be making a fist with your Oculus touch controllers or else it won't register. And as you can see right here, we have found the boss door actually, which is red, but we can't go in it because we don't have the hammer, which is a pickup item that you need in order to get into the boss door. Right now you can see we have a lot of enemies spawning. That uses filtered randomness to see how many enemies spawn in a room, but it's also determined by how many rooms you have gone through without killing enemies. So the more rooms you go through without killing enemies, the more enemies spawn, making it harder to finish the game. And as you can see, the enemies are they go in an idle state. They walk around the nav mesh in the scene, but when you go in their certain radius, they start to attack you, and you lose health, which you can see in your map. Now, to skip to the actual boss, because it takes quite a while to find the dungeon room, and just for the sake of time, we have the 2 hammers here that you pick up, and once you pick the 2 hammers up, the moles start going up, and you have to get as many moles as possible within the time limit. To select which moles go up, that uses filtered randomness, which determines the standard deviation of the moles, and if the standard deviation is too low for the selected mole, then another mole will be selected. The hammers have colliders, and if you hit the collider with the mole collider, then the moles will change states, because they have a state machine, from going up or up to going down, and only moles that are down are selected to go up. So as you can see above, we have our score getting updated real time, and yeah, that's basically the gist of our game. Go through the dungeon, find the hammer, go through the boss door, and then fight the boss. Thank you for watching.